Welcome back to Data Dive, the podcast where we explore the fascinating world of data management and analytics. Today, we're diving into the intricacies of transaction processing and analytics, two critical components of modern data systems. As businesses increasingly rely on data to make informed decisions, understanding the differences and applications of these systems is more important than ever. So grab your headphones and let's get started. Let's begin by setting the stage with transaction processing. In the early days of data management, a transaction was simply a record of a commercial activity. Think sales, orders, or payroll. As databases evolved, this concept expanded. Now, a transaction can refer to any logical grouping of reads and writes, even if it doesn't involve money. At its core, transaction processing is about enabling low-latency reads and writes. This is crucial for applications where users expect immediate feedback, like when they make a purchase online or update their contact information. We often refer to this type of processing as online transaction processing, or OLTP. On the other hand, we have online analytical processing, or OLAP. While OLTP focuses on quick, real-time transactions, OLAP is all about analyzing large datasets to derive insights. Imagine a business wanting to know its total revenue for January or which products are frequently bought together. These queries typically involve scanning vast amounts of data and calculating aggregates rather than simply retrieving records. Now let's dig deeper into the differences between OLTP and OLAP. We can summarize their characteristics in a few key points. First, OLTP systems are designed for random access, low-latency writes based on user input, while OLAP systems often rely on bulk imports or streams of events for data processing. Next, OLTP is primarily used by end users or customers through web applications, whereas OLAP is utilized by internal analysts for decision-making. Finally, OLAP databases reflect the latest state of data at a given moment, while OLAP databases contain historical data that chronicles events over time. Despite these differences, both OLTP and OLAP systems can utilize SQL for querying. However, in the late 1980s and early 1990s, many companies began separating their OLTP and OLAP systems. This led to the creation of data warehouses, dedicated repositories designed specifically for analytics. So, why did this separation happen? OLTP systems are often complex and critical to business operations, requiring high availability and low latency. Database administrators are typically cautious about allowing heavy analytic queries on these systems, since they can slow down transaction processing. This is where data warehouses come into play. They provide a read-only copy of data extracted from OLTP systems, allowing analysts to run queries without impacting the performance of transactional operations. The process of getting data into a warehouse is known as extract, transform, load, or ETL. The beauty of a data warehouse is that it can be optimized for analytic access patterns. For example, while OLTP systems might rely on traditional indexing algorithms, data warehouses can employ techniques better suited for large-scale analytics. Now, let's talk about the structure of data warehouses. Many of them utilize a model called the star schema. Picture this. At the center, you have a fact table that records events, like sales transactions. Surrounding this fact table are dimension tables that provide context. Think product details, store locations, and time periods. This structure allows for flexible analysis, though it can lead to very large datasets, especially for major enterprises. For instance, a company like Walmart might have petabytes of transaction history stored in its data warehouse. Each row in the fact table represents a unique event, such as a customer purchase, while dimension tables offer additional details that can be crucial for in-depth analysis. However, querying these large datasets efficiently can be a challenge. Analysts typically don't need to access every column in a table. They often focus on just a few relevant ones. For example, if an analyst wants to know how many fresh fruits or candies were sold on specific days, they might only need to access a handful of columns, even if the fact table contains hundreds. To tackle this, many data warehouses utilize column-oriented storage. Instead of storing entire rows together, data is organized by columns, allowing for more efficient querying, particularly for analytical workloads, as it minimizes the amount of data that needs to be scanned. As we wrap up this segment, it's important to note that while OLTP and OLAP systems can sometimes be integrated within the same product, they are increasingly being developed as separate engines. This separation allows for better optimization tailored to their specific needs, even though they can still be accessed through a common SQL interface. In conclusion, understanding the differences between transaction processing and analytics is essential for anyone working with data today. As businesses continue to leverage data for strategic decision-making, the ability to distinguish between OLTP and OLAP systems will only become more critical. Whether you're managing customer transactions or analyzing historical trends, knowing how to navigate these systems can empower you to make better, data-driven decisions. Thanks for tuning in to this episode of Data Dive. We hope you found our exploration of transaction processing and analytics insightful. Don't forget to subscribe for more discussions on data management and analytics. Until next time, keep diving into the data.